What is going on, guys? Vlad here with SolosPLC.com, and this morning I wanted to make some connections to my Cognex cameras in order to program a new inspection system. And some of these cameras I've showed you in one of my recent vlog videos, but essentially a topic that I wanted to get back to before we get into the camera systems is bit manipulation. So I've released a video last week that talked about some basic bit manipulation through masking. That being said, a couple of you asked me questions on the BTD instructions, the move and the COP. So those are the fundamental instructions for PLC programming in order to manipulate ins to, let's say, dents to sense. So ultimately, I'm going to be walking you through the differences in those three instructions. We're going to be building a fairly simple program, but ultimately I'm going to be explaining how those different elements interact with each other, and it's something that I recommend you know about because the tie to the Cognex cameras is that the data is often essentially unfiltered. So what you would get is a bunch of bits that are, for example, if you read a barcode or if you read a length, you would get a certain number of bits that are going to be, let's say, the camera identifier, and you need to be able to shift the bits effectively in order to retrieve the value that you're looking for. So there's a lot of applications for those bit manipulation instructions. They could also be used in weight scales. I've seen them used with different other third-party hardware, and ultimately it's just a really good thing to know, not only in general software practice but in PLC programming. Before we get started with today's video, we just wanted to quickly point out all the great content we've been releasing on the Solos PLC YouTube channel. And this includes industrial automation, PLC programming, as well as HMI development. And if you enjoy this type of content, we would really appreciate it if you could click the subscribe button as well as the notification bell in order to receive the latest and greatest content we will be posting to the channel. Alright, so here we are looking at a brand new routine, which is called BTD under this advanced program. And here we have absolutely nothing written right now. I've got a few registers that I've set up. But first we're going to look at the very basic instruction, which is going to be the move. Once again, I typically use any instruction on my list, and then I type in the name of the instruction, most of which I have memorized. And then you have a source and a destination. So like I was saying, I already have pre-created a couple of integers and double integers, so we can start using them. So let's say I move this integer into this double integer, which you've probably seen many times, and you probably already know what's going to happen. So I'm just going to compile this and edit this first integer. So let's say if I want to copy this 56, then all it does is move this 56 into this 56. Now there's a very important distinction in this, in the sense that there's an integer that's being moved into a double integer. And if we right click it and go into monitor and look at both of those values, you'll see that first of all I have set them already to binary. You can do so by clicking on this little drop down menu, and you can change from decimal to binary, which allows you to get a better view of those bits. Now you obviously know from a previous video that there's going to be 16 bits in an integer and 32 in a double integer. So what happens if we start changing, for example, this value to these 4 ones? You'll notice that the move instruction completely overwrites everything that's left of the value to zeros, right? So in this case, we've got all zeros here, and we've got the same value inside of these 16 bits that we have in this integer. And that's a very important distinction from a bit BTD instruction, which we'll look at next. So let's go back to the program and let's change this from a move to a BTD. So if I do BTD, bit field distribute, and I'm moving the same exact integer into my, let's see here, so I'm going to put that in the destination, and I'm just going to manipulate this to make sure that it's the same as the move just for now, and I'm going to move 16 bits. So of course the length of the integer, like I said, was 16 bits. So this should be exactly the same as we had before. Now this is very important. So we're moving 16 bits. If we go back to our instructions, to our integer and double integer, you'll notice that the same thing is still happening. Let's just reset this. I'm going to put this into decimal and I'm going to set this to 0 so that it can take. So 67 is moved into 67. Now, that's all great. However, let's see if we can change these 4 zeros to 1s. And you'll notice that as soon as I press enter, these 4 1s are going to stay there, right? So we're moving these 16 bits into these first 16 bits in our double integer, and everything else is ignored. Now let's change this instruction and make that 32. Let's see what happens in this case. Let's go back here, and you'll notice that the 1s have disappeared. And of course, if I type them back in, they're going to go back to all the zeros. So essentially, this bit field distribute instruction is working like a move in this specific configuration. All right, so the next thing we're going to look at is going to be the destination bit, since it's a little bit easier to understand than the source. So the destination bit is essentially at which point in the double integer should we start copying the integer into. So let's see if we can change this to a 2. And I'm also going to make this a little bit more obvious on the other side. Let's see here. So we're going to compile the program, press yes. I'm going to control tab back into my tags, monitor tags. And let's see here. Let's just make this one like a 1 0 1 0 1 0 1 0. Perfect. So we've got that value in here. Let's set this one back to 0 so that we can rewrite into it. And you'll notice that the first bit here, or let's say the first 4 bits are 1 0 1 0. Since we've set our destination bit to 2, the first bit of this integer is going to be written in the second bit of the double integer. And so from that point on, the pattern is going to repeat just as we had in the integer. All we're really doing is shifting these 8 bits from starting at 0 and going all the way up to 7. They're now starting at 9 and going all the way down to 2. And essentially that's how that works. If we modify this once again and we set this to 8 and write this in, then you'll notice, so first of all, we do need to reset since we're not writing any zeros at the beginning. You'll notice that we're writing those same, essentially 16 bits into the center of that double integer. And let me just put some more 1s and 0s so it's a little bit more obvious. Okay, perfect. So our entire integer is just an array of 1s and 0s alternating, and you'll notice that now it's positioned right at the center of the double integer. So we've essentially skipped 8 bits, which is specified by the destination bit. Now, of course, you can create some logic that allows you to manipulate this even better. So for example, if you have 2 different integers, you can swap them within the double integer. So let's look at that really quickly. Let's edit this, and I'm going to just paste another bit field distribute instruction. And what I'm going to do here is I'm going to have a array number 1 that's going to be written to the same one. Let's see here. So here it's going to be 16. Here it's going to be 0. I'm going to compile this in. And then I'm going to look at this side. Let's see. So now we're writing both of these integers into one double int. And let's see here if I put this all 1s. Okay. So we've got all those 1s, and then we should still be distributing. Let's see. We need to come back and change the length. So the length is going to be 16. Otherwise, we rewrite zeros into those bits. We're going to compile this back together. And what you'll notice is that this first integer is being put at the end of the double integer, and the second integer is being put at the beginning of the double integer. And this, of course, opens the door to very different and interesting manipulations that you can do. You can, of course, reverse them. So if you were to write this one at destination bit 0 and this one at destination bit 16, we would get the opposite result. So let's just compile that. And you'll notice that if we switch back into our tags, now the first integer is written at the beginning of the double integer and the second one is written at the end. And now this is something that you could not achieve with a simple move instruction. So this allows you to stitch integers into a single double integer together. Now, if you want to, for example, start at a different location of the integer, you would have to modify the source bit. So the source bit is essentially a reference to the source element, while the destination bit is, as the name would suggest, the reference to the destination bit. So here, let's modify this and let's put 8 for each one of them. Let's see what the result is going to be. We're going to compile this and we're going to tab back into our program. I'm just going to write a 0 into this so that we can get a clear picture. And you'll notice that what we're doing is we're copying the final 8 bits of our integer 1 into the first 8 bits of the double integer. And the next thing that we're doing, of course, is we're copying 4 bits of this integer into the first, or I guess the 24th to the 16th bits of the double integer. And you can notice that you can create any pattern with this essentially. So we can start manipulating in a much more complex way. So I could say that, for example, I want only 8 bits of this and I want them at the beginning, and then I want this to come in. Let's see here. So we're going to come in starting from 0. I'm going to start at 8. And what I'm going to do is I'm going to add yet another bit field distribute, and I'm going to move the other integer once again, starting from a destination bit 24. And I'm going to start this at 8. And this is going to be 8. So this will become clear in just a second. Let's first look at the tags. Let's reset this to 0. Okay, so what we've got here is a very interesting combination. And essentially what we're doing is we're taking 8 bits out of the first integer, putting them at the beginning of the double integer. Then we're putting all the 16 bits into the center, right? And then we're putting the last 8 bits of the integer at the end of the double integer. So just some very clever ways to manipulate the data. And once again, this is not something that you would do just, I guess, to manipulate the bits. But typically in third-party hardware, you will have data coming in different locations within those elements. So it becomes very, very useful. Thank you guys so much for watching my content. If you have any questions on this topic, make sure to leave them in the comment section below. And if you can spend 5 seconds of your time liking as well as sharing that video if you've enjoyed it, that would mean absolutely the world to me. And if you have any suggestions for the channel, what kind of hardware, software I should be covering, then make sure to leave that down there as well. See you next time. Take care. Bye.